Hey there and welcome to our video. Today, we're going to be taking a deep dive into the future of transportation, innovations and challenges to help you gain a better understanding of it. So sit tight and let's get started. The flying cars are vanished. Where are the passenger supersonic jets? Around the corner. Either incremental or dramatic changes are made to transportation. A greater integration of physical and information systems will impact transportation in the future. The magnitude and scope of transportation have remained fixed throughout human history. Since the invention of mechanized transportation 2 centuries ago, the capacity, speed, efficiency, and geographic reach of transportation networks have all significantly increased. The fundamental driving force behind advancements in transportation technology continues to be the desire to move people and goods more quickly, in greater quantities, safely, and efficiently. Networks, modes, and terminals have all seen notable alterations that have 2 functional implications. Number 2. Automation and information technologies. With the late 1960 advent of commercial jet flights, high-speed train networks, and the container, no paradigm-shifting technical change has changed passenger and freight transport systems. Early 21st century car and truck dependence inhibits alternative mobility. Paradigm shifts may create the biggest transportation technical change since the car. ICT is being used to automate automobiles and terminals to improve mobility speed, efficiency, safety, and dependability. These technologies could improve automated highway networks or build new modes in transshipment systems for autonomous vehicles, public transit, and freight transportation. Automation affects transportation and related jobs. GPS, sensors, and mobile connectivity have improved navigation and congestion mitigation. The Internet of Things is forming. These devices improve routing and demand predictions in automobiles and containers. Predictive analysis and sensor reports can preserve transport assets and reroute vehicles during congestion. On-demand mobility services use taxis and private cars. Real-time fleet management and leasing reduce the number of cars needed for mobility. Less parking lowers congestion in dense areas. On-demand services outperform taxis by 30 and 50%. This productivity improvement is attributable to more efficient driver-passenger matching technology, the massive scale of on-demand car services, strict taxi restrictions, flexible supply models, and yield management systems. Leasing replaces private car ownership. Driverless automobiles add ICT to transportation. Urban safety considerations prevent such deployment. When driver behavior causes bottlenecks, better vehicle navigation and cooperation can drastically reduce congestion. Fewer accidents reduce congestion. Automation technology is unsafe, especially in flight. Hence, air cargo operations use more remote-controlled planes. Automation has reduced ship workers in recent decades, opening up maritime transportation opportunities. Self-driving trucks are most promising. Automation thrives on long-distance routes and stable driving conditions. Convoys of trucks save fuel. Self-driving trucks can perform repeated short hauls between ports, rail yards, and distribution centers. In 2015, the U.S. had 1.7 million truck drivers. Hence, route-specific autonomous trucks may be introduced. Automated trucks move containers between docks and stacking yards at port terminals. Long-haul truck automation is most automated but least electrified due to powertrain limits. Drones may inspect infrastructure and deliver small supplies. Driverless cars may aid marginalized groups. These would improve vehicle asset utilization. Fewer accidents lower car insurance and social spending. Driverless cars may be lighter and less safe. Fewer parking might free up road and land. Public transit's role in almost on-demand mobility is raised. Numerous well-funded transit systems have consistent or declining patronage. Infrastructure and vehicle management can improve performance. Transit business structures affect ICT diffusion. Number 1. Alternative modes and fuels. Several modes could replace but probably complement existing modes, especially for passenger transportation. Magnetic levitation (maglev) can go 500 and 600 km/h without friction. Low-pressure tubes speed trains. This replaced 75 and 1,000 km passenger and freight land transit. Maglev exceeds 300 km/h high speed rail network technological restrictions. Maglev is the first major railroad invention since the Industrial Revolution. Shanghai opened the first large-scale commercial maglev system at 440 km/h in 2003. 30 km system appears unprofitable. Some guided tube versions use a hyperloop electric induction engine to circulate capsules in a partially depressurized tube. Some localities can bypass infrastructure investments and adopt innovative transport technology. Cellular networks have replaced wired ones in many developing nations. Maglev per hyperloop technology might too. If true, some locations could increase transportation without high-speed rail. Electric car refueling issues electricity availability and grid pressure. Electric cars triple a home's electricity use. Electric vehicles require home wiring and local distribution grid modifications. Switching to electric delivery trucks is tough because distribution centers, 300 electric delivery vehicles use 8 MW each day, 16 times more electricity. A recharge station or equipped highway may wirelessly charge electric vehicles. New materials for vehicles and infrastructure. Polymers and composites in modern airplanes save weight, durability, and maintenance. Modular construction uses innovative materials to build bridges faster. Nanotechnology improves asphalt, concrete, and steel. Longer-lasting infrastructure demands less maintenance. Transportation modes can also accommodate particular constraints. Polar freight is carried by new dirigibles. Micromobility and walking for passengers and freight may increase in car-dependent cities. What do you think about our video? Please let us know in the comments area below. If you enjoyed this video and would want to hear from me again, please subscribe and turn on the notification before leaving. Thank you for watching us.